Have you ever really thought about the secrets a diamond might be hiding? And I'm not talking about just its sparkle. I mean, its entire origin story. It's a story that's getting way more complex these days. So let's just dive right into this hidden world, shall we?
So picture this. You're looking at this brilliant, totally flawless diamond. Could you tell me if it was forged deep inside the earth, like billions of years ago, or if it was cooked up in a lab furnace in just a few weeks? Yeah, just by looking at it? The answer is nope, no way. The difference is completely 100% invisible to the naked eye.
Okay, so how in the world do we solve a mystery like that? Well, we have to become gem detectives. Seriously, the evidence, the real clues, they're locked deep inside the diamond's crystal structure. So for this explainer, we're going on an investigation. We're going to find those chemical fingerprints that will unmask a diamond's true identity. All right, every good investigation starts at the scene of well, in this case, the creation. To find the clues, we've got to understand how these lab-grown diamonds are even made. And we're starting with a method that sounds like it's straight out of some sci-fi movie. It's pretty wild.
It's called the high-pressure, high-temperature method, or, HPHT for short. And yeah, the name pretty much says it all. Scientists are basically recreating the brutal, super intense environment of the Earth's mantle, but they're doing it inside a lab. They use this special furnace to apply just immense pressure and heat to a carbon source. But, and this is super important, there's one more crucial ingredient, a molten metal catalyst.
This process is kind of like a cosmic recipe, really. First, you start with a carbon source. Think something like graphite. Then you dissolve it in this bath of molten metal. We're talking an alloy of iron, nickel, or cobalt usually. Step 3, you just crank up the pressure and the heat. And under these absolutely insane conditions, the carbon atoms start to rearrange themselves, they crystallize, and boom, you've got a perfect diamond.
See? Now that we know how these things are made, we know exactly where to start looking for clues. And remember that molten metal bath? The catalyst in our recipe? That's the key. That's everything. It leaves behind microscopic evidence, those chemical fingerprints we talked about, that you will just never find in a natural diamond.
And that brings us to our number one piece of evidence. The single most definitive clue that tells you a diamond was born in an HPHT furnace. I like to call it the metal's mark.
So what exactly is this metal's mark? Well, as that diamond crystal is growing, it can actually trap tiny little droplets of the molten metal catalyst, the iron, nickel, or cobalt. When you look under a microscope, they just look like these dark, opaque specks, kind of like tiny little fossils from the moment the diamond was created. And here's the real kicker. If there are enough of these metallic bits inside, it can actually make the diamond slightly magnetic. A magnetic diamond? That is a dead giveaway of its lab-grown origin. No question about it.
But wait, the metal isn't the only stowaway here. There's another element that can sometimes sneak its way into the crystal lattice during the HPHT process. And this one messes with the diamond's color.
That element is boron. And boron is interesting because it plays two totally different roles. Sometimes it's just an accident, a little contamination that results in a faint blue tint. Gemologists have a cool name for it. They call it a blue nuance. But other times, scientists add it on purpose to create these absolutely stunning, vivid blue diamonds. The crucial thing to remember is, whether it's an accident or totally intentional, the presence of boron is another huge sign pointing to a lab origin. Oh, and get this, it also makes the diamond electrically conductive. How wild is that? And we've got one more potential impurity to talk about, nitrogen. Now, a lot of these lab processes are aiming for super pure diamonds, right? But sometimes a little bit of nitrogen gets in, and that can give the final stone a yellow or even a brownish tint. It's just another small piece of the puzzle, but it helps us build out that complete picture of the diamond's life story.
Okay, let's recap. We've found our big clues. We've got the metallic inclusions, we've got boron, and we've got nitrogen. But hey, a good detective always considers all the possibilities, right? So what about the other major method for growing diamonds in a lab? Let's take a look, because ruling it out is actually going to make our case even stronger.
So this other process is called chemical vapor deposition, or CVD for short, and it is a completely different ballgame. Instead of crazy high pressure, it uses a low pressure vacuum chamber, and instead of that molten metal bath, it uses hydrocarbon gas. The key phrase here, the most important thing to remember, is no metal catalyst.
And this really makes the distinction crystal clear, doesn't it? HPHT, high pressure molten metal. CVD, low pressure gas. It's that simple.
And that means an HPHT diamond can have those telltale metallic inclusions we've been talking about. But a CVD diamond? Absolutely not. It's impossible. Now, CVD diamonds have their own unique clues, things like graphitic inclusions, but they will never have the metal. And that confirms it for us. Our number one clue, that metal's mark, is exclusive to the HPHT process. Case closed on that front.
So, we've gathered all our evidence. We've ruled out the other possibilities. What does it all mean? I mean, why is all this microscopic detective work so important anyway? Well, it's time for the final verdict.
It all boils down to one word: certainty. These chemical fingerprints we've been hunting for, the metal specks, the traces of boron and nitrogen, they are undeniable proof. There's no arguing with it. And because of them, gemological labs can analyze any diamond and say with total scientific confidence, this came from the Earth, or this came from a lab.
You know, in the end, it really is this simple. Everything we've just talked about comes down to this one core idea. The grand, sweeping story of any diamond, doesn't matter if it's billions of years old or just a few weeks old, that whole story is written in the secret language of its trace elements.
So the next time you see a diamond, glittering under the light, I bet you won't just see its beauty. You might just find yourself wondering, what kind of journey did that diamond take? What hidden chemical fingerprints is it carrying around? What secrets is it just waiting to tell us?